In this machine learning class, we will see evaluating performance of model. That is part 1. In part 1, we will see the supervised learning classification. That is the evaluating performance of classification. Okay, here we will see the different metrics for evaluating the performance of supervised learning. First one is model accuracy, error rate, kappa, sensitivity, specificity, precision and recall. After that we will see the F measure and ROC, that is receiver operating characteristics curve, and AUC, that is the area under curve. Okay, so these are the things we will see in part 1. When come to part 2, that is in the next class we will see the supervised learning regression. After that the unsupervised learning clustering. So those are the things we will see in the next class. Before analyzing the performance of classification, let us see what is classification, right? So classification is assigning class label to the target feature. Assigning class label to the target feature based on the value of predicted feature. Value of predicted feature. Okay, so this is called as classification, right? Here, let us take the cricket match as our example. Now, what is our problem? We need to predict whether the match will win or lose the game, right? So, this is what our problem. So, for predicting the match, whether it will win or lose, we need to consider the following features. What are the features? First one is the weather, okay? And second one is the team won the toss or not, right? And the third one is number of spinners in the team. And fourth one is number of wins the team held in the tournament, entire tournament. Okay, and the number of all-rounders in the team. Okay, so etc. So we need to consider these things before predicting whether the cricket match is winning or losing. Okay. Hence, to evaluate the performance of model, right? The number of correct classifications or predictions that to be recorded. For example, we are having 100 matches. So in the 100 matches, how many predictions are correct? That is, if we predict win, then the match should also be win. Okay, then this is correct. Okay, suppose if we predict lose, okay, the match will lose, then the match will also lose. Okay, the team will also lose the match, then this is also correct prediction. This is also correct prediction. Okay, that is a classification is said to be correct if the given problem it has been predicted by the model that the team will win and it actually win. And it actually won. Okay, suppose if we predict the team will win, then after completing the match the team should also win the match. Okay, then our prediction will be correct. Here, the accuracy of the model is calculated based on the correct and incorrect classification. Okay, based on this classification model, that is whether the model is predicted correctly or incorrectly, accordingly the accuracy of the model is calculated. For example, we are having 100 games. In that, 99 games are predicted correct. That means if we predicted win, then the team will also win the game. If we predict lose, the team will also lose the game. Okay. For example, 99 times we predicted correct means the accuracy is 99%. 99%. Okay. Here there are 4 possibilities for predicting the match, whether the game will win or lose. Okay. Here in this graph, the y-axis represent the predicted outcome and the x-axis represent the actual outcome, right? The first one is the model predicted win and the team also won the match. Okay, so this is called as true positive, right? So the predicted value will be win the team will also win the match. Okay, this is the first one. This is called as true positive. True positive, right? And the second one, the model predicted win and the team lost. Okay, we predicted, that is by using our model, we predicted the team will win, but the actual game, the team will lose the match. Okay, so this is false positive. This is false positive. See, false positive. Okay, and third one is the model predicted loss, but the team won the match. Okay, this is called as false negative. See, this is false negative, right? Actually, the team won the match, but we predicted lose, isn't it? Okay, this is false negative. And the last one, the model predicted loss and the team also lost. Okay, so this is called as true negative. See, this is true negative. Hence, this one and this one are correct, right? And now let us see the performance measure of supervised learning. Here, in this performance measure, we will see the model accuracy, error rate, kappa, sensitivity, specificity, precision, and recall. Okay, let us see all those things one by one. Before all those things, first let us see the confusion matrix. What is confusion matrix? This matrix containing the correct and incorrect predictions in the form of true positive, false positive, true negative, and that is false negative and true negative. Okay, so this is called as confusion matrix. Okay, let us see the example for this confusion matrix, that is 2 by 2 confusion matrix. Here the prediction and the actual. Okay, prediction win and actual win is 85. Prediction win and actual loss is 4. Okay, prediction loss and actual win is 2, and the predicted that is loss and actual also loss are 9. Okay, so these are the given value. From these given value we need to compute all those things, right? First, let us compute this model accuracy. Okay, model accuracy is nothing but the percentage of correct classification. Okay, correct classification means true positive and true negative, right? So from the confusion matrix, this is true positive and this is true negative, right? Here, and this is um, false positive and this is false negative. This is true positive, this is true negative, right? So we try to substitute the values for this variable, right? 85 plus 9 divided by all the values, 85 plus 4 plus 2 plus 9. Okay, that is true positive, false positive, true negative and false negative, right? So the total value is 100 and correct prediction is 94. Hence the model accuracy is 94%. The second one is error rate. Error rate is nothing but the percentage of misclassification. Okay, so this is called as error rate. Okay, the formula for error rate is false positive plus false negative divided by all the values, that is true positive plus true negative plus false positive plus false negative, right? And the other formula for this error rate is 1 minus model accuracy. 1 minus model accuracy. So from the confusion matrix, 1 minus model accuracy is 0.94, isn't it? So 1 minus 0.94 is 0.06, which is otherwise called as 6%, right? So let us try to substitute the values for these variables. 4 plus 2, that is false positive is 4 and false negative is 2, divided by 100, all the values. So 6 divided by 100, which is equal to 6%. And the next one is kappa, that is the third one. This is nothing but the adjusted model accuracy, right? So this is called as kappa. The formula for kappa is P of A minus P of PR divided by 1 minus P of PR. Here the P of A is nothing but the model accuracy. Model accuracy, and these are the expected adjustment between the model accuracy. Okay, that is P of A, which is equal to the proportion of observed agreement between the actual and predicted in overall data set, right? Okay, so this is P of A, which is nothing but model accuracy. Okay, how many percentage of correct prediction the model will produce, that is called as model accuracy, isn't it? And next one is P of PR. P of PR is nothing but the proposition of expected agreement. This is important. Okay, what expectation from the given model. Okay, so this is proposition of expected agreement between actual and predicted data. Okay, and this is the formula for PR. Okay, this is the formula for P of PR. Right, now let us try to substitute these values with the value, these variables with the values, right? So from the formula we will get the P of A value is 94, right? And P of PR value is 0.7886. Okay, P of PR. Okay, now let us try to substitute the values, then we will get these values. And K value is P of A minus P of PR divided by 1 minus P of PR, which is equal to 0.7162. So this is kappa K value. The fourth one is sensitivity. Okay, sensitivity is nothing but the positive values from the correctly classified values. So this is called as sensitivity, that is true positive divided by true positive plus false negative. Okay, so from the confusion matrix we already know the values. We try to substitute the values with the corresponding variables, then we will get 97.7%. So this is sensitivity. Sensitivity is nothing but true positive divided by true positive plus false negative. The next one is specificity. This is the opposite of sensitivity. Okay, so this is nothing but the model measures the proposition of negative examples, okay, which have been correctly classified. The negative examples which correctly classified, that is true negative divided by true negative plus false positive. Okay, so this is 69.2%. The next one is precision. Precision is nothing but the proposition of positive predictions. Positive predictions which are truly positive. Okay, so precision which is equal to true positive divided by true positive plus false positive. Okay, so this is called as precision, and the precision value as per our example is 95.5%. The next one is recall. Recall is nothing but the proportion of correct prediction of positives, the over that is the total number of positives. Okay, so recall is nothing but the true positive divided by true positive plus false negative. True positive plus false negative. Okay, so the percentage is 97.7 as per our example. F measure. F measure is nothing but the combination of precision and recall. The formula for F measure is 2 into precision into recall divided by precision plus recall. Okay, so here the value is 96.6. So as per our example, the precision is 0.955 and the recall is 0.977. Right? So the value is 96.6%. Here the F score is combination of multiple measures into one. Okay, for example, the combination of precision and recall, right? So the F score is used to compare the performance of different models. Okay, for example, by using the precision and recall, we can compute the F score value, that is F measure, isn't it? Here the prediction and precision and recall are having equal weight, right? But certain problem, we have to give more weight for this precision when compared to recall. For example, disease prediction problem. So in disease prediction problem, we have to give more importance only for this precision, right? But some cases we have to give more weightage for recall also, right? Here some serious problem, we have to assign some specific values for both precision and recall, right? So the precision and recall values are dependent on the problem. And now let us see some of the other models to predict the performance of supervised learning methodology, right? The first one is visualization. Visualization is nothing but plotting the data into a graph. Plotting a graph by using the given data, right? So by seeing the graph, we can easily understand the performance of the model performance. Here two methodologies are there. First one is receiver operating characteristics curves, that is ROC curve, and second one is area under curve, okay, AUC curve, okay. And it also helps in comparing the efficiency of two models. When if we visualize, see, two classifiers are there. By using this visualization, we can easily understand the performance of these two classifiers, right? First, let us see this ROC, which is used to visualize the performance of a classification model. For example, this is the visualization of data. By using this particular ROC model, we can easily understand the performance of a classification model methodology. Okay, and it also shows the efficiency of the model. Okay, how efficiency the model is by deducting the true positives. How many true positives are there? Based on that, we can easily understand the efficiency of the given supervised learning model. Okay, it refresh our memory with true positives. True positives. This is important here because the model has correctly classified the data instance. Model has correctly classified the data instance as the class of interest, right? That is how many true positives there in a model. For example, let us take this tumor malignancy prediction problem. That is whether the tumor is serious or a mild one. If it is serious, then our model should predict this is a malignant. Okay, then this is true positive. True positive, isn't it? Otherwise, we will get the false positive rate, right? That means the model incorrectly classified the data instance. Okay, false positive. Here we need to compute the true positive rate and false positive rate. True positive rate means true positive divided by true positive plus false negative. Okay, this is TPR. TPR is nothing but true positive rate. And next one is false positive rate. So this is false positive divided by false positive plus true negative. False positive plus true negative. Here the x-axis represent the false positive rate and y-axis represent the true positive rate, right? And we assume the lower value of classification threshold. That means more number of items are positive. Okay, that means if the true positive rate is increased, if true positive rate is increased, then false positive rate should also be increased here, right? So this is ROC curve. Next, let us see this AUC. AUC is nothing but area under curve. Here, the two-dimensional space that starts from 0, 0 to 1, 1. Okay. In x-axis, which represent the false positive rate, that is 1 minus specificity, and y-axis, which represent true positive rate, that is sensitivity. Here, each point on this curve, okay, each point on this curve represent the true and false positive values. Okay, and this curve gives the indication of predictive quality of your model. Okay, here we are having two classifications. The first one is classifier 2 and second one is classifier 1. Right? Here, the AUC of classifier 1 is more than AUC of classifier 2. See, classifier 1 values are more when compared to classifier 2 values. Hence, the inference of classifier 1 is better than classifier 2. In AUC, the predicted value lies between 0.5 to 0.6 means there is no predictive ability for this model. Okay, if the predicted value lies between 0.6 to 7 means the prediction is very weak, and if lies between 0.7 to 8 means fair, and 0.8 to 9 means good predictive, and 0.9 to 1 means excellent predictive ability. If it less than 0 to 0.5 means there is no predictive ability, right? The prediction is very poor. So far we have seen evaluating performance of a model, that is the first model, supervised learning, that is classification. By using various formulas, we have find the performance of this particular model, that is classification model. Right? In the next class we will see the performance of, that is evaluating performance of supervised learning, that is regression. After that we will see the supervised, that is unsupervised learning, that is clustering. Okay, so these two performance methodology we will see in the next class. Thank you.